In college algebra, we started 1.7 yesterday, just barely because we were finishing up another handout. Now we're going to wrap it up. So to graph -1 less than x less than or equal to 3, you make a number line and make 2 dashes. -1 and 3. Make a circle at -1 because it's just a less than. And less than or equal means use a solid dot. And we shade in between because x is between the two. On number 2, you see parentheses and brackets. If you see a parenthesis, you're going to use a less than or a greater than. And if you see a bracket, you're going to use a less than or equals, or greater than or equals. So like on 2a, first start out by writing -1, x, and 4. And see there's a parenthesis by -1, so I'm just going to write a less than. And bracket by the 4, so I'm going to write less than or equals. You're actually always going to write a less than. It's just a question of if it's a or equals or not. Make a graph. Make an open circle and a solid dot and shade in between. Part B, you're going to have 2 brackets. So 2.5 is less than or equal to x less than or equal to 4. Draw a number line, and I bet you get the idea now. This last one on number 2, you can write too much. So that is plenty right there. Notice there's no bound on the right side. That's an infinity symbol. So it just means that x goes forever to the right of -4. So the way I have it written, you could plug in any number that is larger than -4 and you get a true statement. If you write this, that's a little bit redundant, not necessary to write that. I would just write that right there. Because to graph it, you just need 1 dash. Make a circle and shade to the right. All right. On number 3, now we got to start solving these. We have things that look a little closer to equations here. So on number 3, we're going to treat the less than sign just like an equal sign, except the one difference in how we handle it is if you divide or multiply by a negative, then you must flip the inequality. So on number 3, we want to subtract 3 from both sides. And we get 8. Then we want to divide by -2. And in your notes, you need to somehow make this stand out because we're going to flip the inequality. So now x is larger than negative 4. Make it on a graph. And shade to the right. Because x is bigger. Let's try number 4. I like x's on the left, so I'm going to do that. If you want to get x's on the right, that way you don't get a negative x, then you should get the same answer as me. But I'm going to move numbers to the right side. Subtract 13x. We haven't divided or multiplied by a negative yet, so we're safe. No flipping needed yet. Now we're going to divide by negative 6. And we do need to flip that inequality to a greater. Or sorry, to a less than. All right. The graph looks like this. Make a solid dot and shade left. You know, if you're ever nervous, you flipped it the wrong way or you messed up, plug in a number that should work. If you plug in -7, -10, -20, you should get a true statement. All right, moving to the back. Almost done. Number 5, we have a compound inequality. The same rule applies in terms of whatever you do on one side, you do to the other. It's just we have 3 sides now. We have a left, we have a middle, we have a right. So if I'm trying to get x by itself, I want to subtract 1. I got to do that to all sides. And we end up with -4 less than 2x less than or equal to 2. Then you half everything, and x will be all by itself. Am I dividing by a negative? Nope. We do not have to flip the inequality. So our graph looks something like this. On number 6, we did one similar to it yesterday, and we need to take into account that the inside might be positive or negative. So the first way you write it is x minus 4 less than 3. No changes, just get rid of the bars. But the other way we want to account for is x minus 4 greater than -3. So for the other scenario, you want to flip the signs on one side and flip the inequality. And it'll work every time. Add 4. And x is smaller than 7. Add 4. And x is larger than 1. These two agree. This isn't an or situation. This is an and situation. This means 1 is less than x, which is also less than 7. On the graph, it makes a lot of sense to write it as 1. Because when I shade greater than 1, it only works between the two numbers. If you try and plug in an 8, it will not work on x less than 7. It has to work for both. All right? Try and plug in an 8 to the original problem, and you get a false statement. All right, let's try one more of those. 2x plus 3 greater than or equal to 5, or 2x plus 3 less than or equal to negative 5. Solve for x. Solve for x. And notice these do not overlap. X is larger than 1, but it also says x is smaller than negative 4. We got to leave it like that. You can't write it into a compound inequality. There's no way they can both be true. So it's an or statement, which means on the number line, they are completely separated. Whoops, we need a negative 4. We need solid dots. And for that negative 4, it says x is smaller than negative 4, so you shade left. And it says x is larger than 1, so you shade right. Notice they do not overlap. All right, last problem. It's a word problem about renting a car. So maybe hit pause and write an equation for A and for I. A should be 4 plus 15x or 15m, something like that, because we're charging mileage for a day. This is a plan for just a single day. Notice it says daily cost right here. So the number of days is not in question. For interstate, 20 bucks a day plus 5 cents a mile. All right, here's the catch. When is Acme better? You're a customer. Better means cheaper. When is Acme cheaper? Or in math world, when is A smaller than I? So you plug in your two expressions, two equations. Get x by itself. Divide by 0.1, and you get x is less than 160 miles. Acme is cheaper when driving less than 160 miles. All right, that was all we did today. I will see y'all later. Bye.